Hi everyone. In this video, we're going to see how the web works. We're going to take a break from HTML and see what really happens when you load a page in your browser. As with any area of study or profession, it's good to have a thorough, deep understanding of what really happens in your environment when you write HTML or some code. In this video, I'm going to try to keep a balance between going too much into detail and getting people lost, and not going into enough detail where it's pretty much everything you already know. So let's get started. I'm going to start by illustrating what happens when we request a web page on a browser. Okay, say you're at your desk and you're at your monitor. And this is your browser. So you type in a URL here, Amazon.com, Google.com, whatever it may be, and then you hit enter to load the page. What happens behind the scene is your browser constructs what's called a request, an HTTP request, and that has information like the date, the client that you're using. It can either be a browser, what type of browser, is it Firefox, is it Chrome, is it Safari, if you're on a mobile device or tablet, what kind of tablet it is. So that's in here also inside this request. The accepted type that you're expecting back. So in this case, we want an HTML type, so that's listed in there. What else? The IP that your computer belongs to, so that's your address, and any cookies that pertain to the website that you're requesting. So all of this data and some extra data gets created in this request and is ready to be sent off to the server to send back your page. But before it does that, it does something where it breaks up the request into smaller chunks called packets. And this is where the power of the web comes in, because these packets move individually. So they break up here. So they break up into little packets, and they move individually to the server, back and forth. And at the destination, when they arrive at where they need to be, they're put back together into the correct order to create the request again. So let's see how that works. So the packet goes through your internet connection, through your modem, and out to first your ISP servers. Your ISP, or internet service provider, is the company like Cox Cable, Spectrum, Comcast, whoever you get your internet from. They have servers here to capture all your data. So it's kind of like a wall that you have to pass through to get out to the internet, which is out here. So the request gets sent here, and remember, these are packets being sent. And then from the ISP, it goes to, let's pretend we're sending a request to google.com. Okay, so the URL is http://google.com. It hits your ISP, the ISP sends it to another server. So this is a server, this is a server. And if you don't know what a server is, it's basically just another computer, but it's a more powerful, usually a more powerful computer, and it's built for a very specific reason. We have web servers, we have email servers, we have, in this case, a domain name server, or DNS. And the job of the DNS is to convert your friendly URL, google.com, into what's called an IP address. And maybe you've seen this. It's usually a number separated by dots. So it can be, let's say 178.3.259.604. So that's usually a format of an IP address. There's 3 numbers, or at least between 1 and 3 numbers, a dot, another set of one to three numbers, another dot, another set, a dot, and another set. So the DNS says, okay, you're looking for google.com. Well, the actual IP is 178.3.259.604. And this IP address is basically the home address of where google.com's homepage lives. So now we know where to go. I would also like to mention that there are multiple DNSs on the internet. So there's not only one. There are many, many servers around the world. So this is a DNS. This may be a DNS over here. But it just so happened we hit this one, and then it redirects us to this IP. Now let's say that IP exists all the way over here, and this could be on the other side of the world, it could be on the other side of the country, it could be on the other side of the street. But this is Google's web server, and this is where we want to end up. So to get from the DNS to Google's web server, to get the web page, it's not one straight hop over. These packets are gonna take different routes through different servers, and these are, some of them are routers, some of them are other servers, but they don't all go the same way. So I should just make server here, server here, server here, server here. And so some packets go this way, some packets go that way, some packets go this way. And from there might be another server in between. And every server is what's called a hop. So there might be multiple hops to get to the final destination. Or it might go from here to there directly, who knows. Let's say there's another server here, and then it finally gets here. Okay, so when the Google server, their web server, finally gets our requests, or I should say packets that make up the requests, it gets these packets, reorganizes them into the proper order, so it constructs a full request and knows exactly what we're looking for. So let's say, I'm not sure about this, but let's say Google's homepage is index.html. Okay, so our request says we need index.html, please give it to us. So Google's server reads the request and say, hey, I have it, here you go. So Google creates or has the index page here. And once again, because it's the web, it has to go all the way to the other side of the world or other side of the country. It gets broken up into packets. And these are sent back, not the way they came, or it could be, but in a random fashion, they're sent back to our computer. So let's say we send some packets down here, sent some packets another route that it didn't take when it came through. Maybe it took this server also to get here. Maybe some went this way, then maybe some went that way, and then back this way. But this is all determined by these servers, and they try to find the best route to get back to the destination, which right now is back to our computer. So eventually it goes from here and it goes back to the ISP server, because all traffic incoming and outgoing has to go through our internet service provider, right? And then from there, the packets are sent down to our computer finally, where they are reconstructed into the HTML page. And then our browser can read the HTML page and load it up on the screen for us. But that doesn't end the journey because all we got was HTML. We didn't get any of the other assets. We didn't get any images, any CSS files, any JavaScript files. Those we don't know about until we get the first HTML, or actually the HTML. And when the browser reads the HTML and sees that it needs other resources, it'll make more requests back out to the ISP, to the DNS, and all the way back to Google for an image or JavaScript or whatever. Go back to Google, but this time the request is for an image and not for an HTML page, so the request will look slightly different. Google sees that you're looking for an image, says, hey, I do have it, here you go, sends it back through the routers, through all these servers, and then maybe there's another server here that just happened to be involved on this trip, to your ISP, and then the image is sent down to your computer. And it does this for every resource that's on the page. So for every image, it makes another request out, and then it comes back in. So if there's an image, goes out. Another image goes out again. A CSS file it needs goes out. A JavaScript, it goes out. And so when you request a page, it's not just one request, it's several requests depending on how complex the page is. And so this back and forth happens, usually under a second. It happens so fast when you're getting a resource from across the world, which is crazy if you think about it, because that's how far technology has come, where we can access to something on the other side of the world, in China, in England, Ireland, in less than a second. Okay, so just to drive home the point, let me show you a real world example by loading a web page and analyzing the traffic. Okay, here I loaded cheese.com /cheddar. Cheddar is the page. You probably expect something like cheddar.html or cheddar.htm, but there are some web servers that know what to serve up just by typing in something that looks like this without the HTML. And the reason they do this is it looks cleaner. Instead of typing cheddar.html, you can just end it with cheddar, and it'll load. It knows what page to serve up. But let me press F12 to bring up the dev tool so you can see the traffic. Okay, so this is Chrome's dev tool, and right now we're interested in the network tab. And this will show us the network traffic when we load the page. So right now it's empty. I'm gonna refresh and see all the traffic. Okay, what we have here on the top is a sort of bar chart. And each bar represents a request. It's kind of small, so it's not much use, but below that we have the list of requests to the cheese.com web server. And you can see that the very first one at the top is the page name, which is just cheddar, and the type is a document, meaning it's an HTML. Now when I click on it, here is the part of the request that I said that our browser constructs and sends over. Accept is we accept HTML. The user agent, which is the browser, is Mozilla 5.0, and a bunch of other things that get sent over to the web server so it knows what kind of response to send back. And if we want to look at the response that the cheese.com server sent back, in this case the HTML, we go to response. Let me make this bigger. And we can see the actual HTML that got sent back. And it's pretty lengthy. But the important thing here is to note that for any additional resource, there's another request for it. So there's a style sheet here, and the URL is cheese.com. It doesn't show here, but it's implied. It's cheese.com/media/css/lt_page.css. So when my browser got this HTML back, it tries to render a page, and it sees that it needs this lt_page.css. So it has to go back to the cheese.com server to get it. And you can see that right over. Let me see if I can find it. It's not always in the same order. lt_page. Where is it? I wonder if I can search for it. Oh, that's strange. It was there when I loaded the first time. Let me reload it again. Oh, there it is. Strange that didn't show up the other time. Okay, so here again is the first request for the HTML page, and then another request for the lt_CSS page. And you can see this type now is a style sheet. It's not a document. It's not an image. And let's take a look at what else we need from the HTML. So we need favicon.svg. I know I saw that somewhere. Probably should have picked a simpler page. Let's see. Let's see if we can search for it. Says it found one, but it's not jumping to it. Oh, there it is. Okay, and there's our favicon, the SVG, another request. This time the type is SVG and XML. So going back to our HTML, you get the idea. So for every resource, style.css, responsive.css, all of these JavaScript files, there needs to be a separate request made to the server. And then you can see that here. So every line item here on the left side, let me get rid of this, is a separate request. Each of these JPEGs need to go in a separate request and come back as a separate response. So when my browser is done going through the HTML and getting all the resources it needs to construct the page, that's when it's able to render the page in full on my browser, on my screen. So see how fast that is. I'm going to just hit refresh, and it's going to make all of those requests in a matter of 1 or 2 seconds. So let's go back to the diagram again just to review. So here again, I just want to drive home the fact of how fast everything works and how the web technology itself is pretty amazing, considering that these small packets get sent over the network to servers who knows where, gets put back together as a request, and then the web server gets what we want, breaks it up into small packets again, and sends it over the network again to our computer. And this is done several times, back and forth, pretty darn quickly, and it's pretty awesome. Okay, that this video ran longer than I thought it would, but I hope you enjoyed it. I hope it made sense. If you have any questions, comments, or suggestions or concerns, please leave them in the comments section below. And if you like this video or other videos, I would appreciate it if you subscribe. That would be great. Help me out a lot. And until next time, keep coding.